Hi folks, Dr. P here. This is Permutations and Combinations assignment question number 15. In how many ways can 4 adults and 5 children be arranged in a single line? So in question 1, or A, it's going to be without restrictions. So this is an example of a fundamental counting principle problem. So we're going to be using the FCP. And so the first thing we need to do is put in the placeholders for, in this case, it's going to be 4 adults and 5 children. So we're looking at 9 placeholders. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we have nine people in total. And that means for that first position here, we have 9 people to choose from. For the second one, we have 8 people to choose from. 7, 6, 5, 4, 3, 2, 1. All right. Now this here is the same thing as 9 factorial. 9 factorial is 362,880 different arrangements. So that is without restrictions. In question B, we want to determine the number of arrangements if children and adults are alternated. So again, this is going to be a fundamental counting principle problem. But this time we have the restriction on here that they are alternated. Okay, so this is a restriction. So we're going to do that one down here. This is B. We're going to put in our 9 placeholders. 2, 3, 4, 5, 6, 7, 8, 9. Now, they're alternated, but there are sort of 2 different scenarios we can imagine. We can imagine the first person being an adult or the first person being a child. So let's look at those 2 scenarios here. So if the first person is an adult, we are going to refer to adults as A and children as C. If the first person is an adult, the second person will be a child. All right? And then they're alternating, so it's going to be adult, child, adult, child, adult, child. So here we have 4 adults. Here's adult number 1, 2, 3, 4. So we've used up all the adults. Okay. For the children, we have 1, 2, 3, 4, but we have 5 children, so that last person will be a child. So this is going to be a problem, right? Because these last 2 positions, well, we are no longer alternating. So the scenario where we're starting with an adult, we cannot use that. So we cannot start with an adult. With an adult. We will have to start with a child. Okay, so if we do sort of the same visual representation here, but we're starting with a child, child, adult, child, adult. So there we have the 4 adults. We have 1, 2, 3, 4 children, and there's your 5th child. Here are the 9 people. Okay, so we have to start with a child. Okay, so now we go back here to our placeholders. So for that first position, we have 5 children to choose from. Okay, and now it's going to be alternating. So I'm actually going to just to be clear here, underneath the placeholders, I'm going to put in whether it's a child or an adult, this is going to be a child, adult, child, adult. So there are 5 children to choose from for the first position, and we're going to do children first. For the third position, now we have 4 children left. 3, 2, 1. Now we go back in and do the adults. So for this position here, the second position, that's the first adult we're going to put in. We have 4 adults to choose from. And then we have 3, 2, 1. Okay. Now if we take a look carefully here, we see that we're going from 5 down to 1 with the children. 5, 4, 3, 2, 1. That's 5 factorial. And for the adults, we're going from 4 and down. 4, 3, 2, 1. That is times 4 factorial. If we evaluate this on our calculator, we're going to get 2,880 arrangements. In C, so in C, the number of arrangements if the adults are all together and the children are all together. Okay, so I'm not going to put in the placeholders here. You could do that. Instead, what I'm going to do is I'm going to represent this with just the letters. Okay, so all of the adults have to be together. So we can start with adult, adult, so 4 adults like that. And then we have the 5 children. So that is one scenario. Or another scenario would be we start with the children. And then we have the adults. 1, 2, 3, 4. Now these are the only 2 scenarios. Right? We cannot have 4 adults anywhere in the middle here, because then we split up the children. So I'm just going to quickly give you an example here. So we cannot have, we can start with 2 children and then suddenly we have 4 adults. Yeah, the adults are together, but the children are not together now. So this does not work. So these are the only 2 scenarios. We already know from example from question B here that the 4 adults and the 4 adults in a row here is going to be 5 factorial. And the 5 children together here is going to be times, sorry, not 4 factorial. 4, it is 4 factorial. I said 4 factorial, but I wrote 5 factorial. So let's fix that. Should be 4 factorial times 5 factorial, or means plus, and here we would have 5 factorial times 4 factorial. So we know that 4 factorial, 5 factorial is 2,880, and it's going to be plus 2,880, and you add that up, you're going to get 5,760 different arrangements. And then finally is D. If all the adults are together, so the children do not have to be together anymore. Okay, and I'm going to represent this using just the letters. So there's going to be several different scenarios here. One of them is going to be this one. There we have the adults together, and then we have the 5 children. 1, 2, 3, 4, 5, which happen to be together here. But another scenario would be that we start with a child, and then we have the 4 adults together. 1, 2, 3, 4, and then we have the rest of the children, which are the 4 children left. 1, 2, 3, 4. There's another scenario where we start with 2 children, then we have the 4 adults, and then we have the remaining 3 children at the end. So you can see that there's going to be 3 more scenarios here. Right? As we are sort of moving this group of adults down the line, so to say. Right? So that means that there are a total of 6 possibilities. 6 scenarios. 6 scenarios where the adults are together. Okay, each one of those scenarios is going to be the 5 factorial times 4 factorial, which we did in the previous question. So that's the number of arrangements for each one of them, but then we have 6 of them, so times 6. And if we evaluate that, we're going to get 17,280. I hope that helps. Until next time, may the math be with you.